planets, asteroid belt, space debris, moons. The sun makes up 99% of the mass of our solar system. That's like unbelievable, isn't it?
What did you say? The sun makes
The
what?
sun makes up 99% of the mass of our solar system.
It'll take like a year to get around the sun.
It's huge. Like we can't even really fathom the massive size. So what else is unique about the sun compared to other stars? It's a single star. Probably about half the stars are part of a star system, usually binary stars, where two stars orbit each other, and there are all kinds of ways they can do that. Like if there's a big size difference, it's kind of like the Earth and the Moon. Sometimes they're like this. If they're fairly similar in size, and then they can do these crazy like figure-8 orbit things that I can't even demonstrate with my hands. There are all kinds of ways that stars can interact, but about half of stars that we know about have a friend that they stick with. So that kind of system is not conducive to a planet like Earth where life can exist. As you can imagine, there's such a varying amount of energy when two stars are moving around each other that you can't keep a constant temperature like Earth would need to support life. So the fact that our sun is a single star, not a binary or multiple group of stars, is going to keep our temperature constant. Our sun has far fewer and less violent solar flares than most stars. We know that it does have solar flares that affect us, knock out our power grid, send radiation our way. Our magnetic field takes care of a lot of that. But sometimes it does affect Earth, but most stars have much more significant solar flares than ours. The sun is huge. It's about 1 million times the size of the Earth. Like if you had a sun ball, you could fit 1 million Earth balls inside of it.
What is it? The diameter is 865,000.
I thought it was the sun compared to the Earth is like the sun is the basketball and the Earth is a golf ball.
It was a
the
Earth was a peppercorn. I remember doing this. It was a basketball and a peppercorn.
Yeah, something like that.
It's like a huge, like the sun,
Like you can't
when
wrap
we
your
did
head
it,
around
the sun was
much
this
less your
room
arms.
and the Earth was like a marble out there or something, right? Like you could put a lot of marbles in this room.
You could put a lot of marbles.
And if you think, like, spheres have a huge volume to surface area ratio. Like if you're doing the candy guessing game and the thing is in a spherical jar or fishbowl, it's going to have way more than a box of that same kind of size.
Yeah, they say that 1 million planets the size of the Earth can fit into the sun.
Yep. And mass-wise, it's 330,000 times the mass of Earth. So that means the Earth is kind of like denser than the sun because the sun is made of light elements, hydrogen and helium. We're made of heavy elements, carbon and silicon, right? So the sun is bigger volume-wise than mass-wise than the Earth is, if that makes any sense. Even though it's 330,000 times the mass of the Earth, it's 2 times 10 to the 30 kilograms, the mass of the sun, we predict. 2 times 10 to the 30 kilograms, that's pretty big. The sun is spherical, much more perfectly spherical than Earth is. The difference between the circumference this way than this way is only 6 kilometers. Right? The Earth is much less perfectly spherical. We're a little bulgy. I think on the equator we're a little bulgy. And planets like Pluto aren't even remotely as spherical as that, and smaller moons. And the gravity, the massive amount of gravity the sun has because of its massive size, helps to form it into that more perfect sphere. The sun, okay, so lots of people say it's an average sized star. Okay, Hank Green on SciShow said it is bigger than 90% of known stars.
What?
I know, I've
What'd you
never
say?
heard that before. I'm a little
What'd you say?
skeptical. On SciShow, Hank Green said that the sun is larger than 90% of known stars.
How many stars are there?
I feel sketchy about that, but Hank doesn't usually steer us wrong, so I thought it was an interesting thing to note. If you guys want to explore the size, I tried to research the comparative size of the sun to other stars, and I really wasn't finding a lot of information in the 15 minutes I dedicated to that
Betelgeuse
search.
is huge compared to the sun.
Yes, and there are very, very big stars.
Creepy name for a star.
But 2/3 of the known stars, this is as far as I got with my research, 2/3 of known stars are red dwarfs. And they are generally smaller than our sun, so that kind of convinced me that maybe there's something to this. And of course, are we talking about size as in mass or size as in like volume? I don't know. So that's kind of complicated. I don't know. But the sun is unique and apparently controversial because I don't know if I believe that figure. There's a lot of, depending on if they're talking about mass or volume or whatever, kind of controversy about how the sun compares to other stars. So Proxima Centauri is the closest star to us. It's 4.2 light years away. So what's a light year?
The distance a light can travel in a year.
Right. So light from the Earth, like if you shine your little laser and it heads out to Proxima Centauri, that laser light will take 4.2 years to get from here to there. Assuming, as it travels in a straight path, it will take 4.2 years.
Time.
It is a long time.
For light, and light travels so fast.
And that's our closest star.
Like, that's our fastest.
Besides the sun.
Wow.
So from the sun to us, it takes 8 minutes for light to arrive, and that's a long way. So
I remember that.
8 minutes instead of 4.2 light years is a long way. But a light year is so other unique relationships between the Earth and the sun. We are exactly in the right place for life to exist. You guys remember from like module 7 or something how the moon is tidally locked to the Earth, meaning we always see the same side of the moon, right? There's a dark side of the moon, and the moon doesn't rotate so that we all see the back of it sometimes and the front of it sometimes, for example. And if we were closer to the sun, we could have become tidally locked with the sun so that one side of the Earth would be really hot and one cold.
Did you know the moon is moving away from the Earth?
Is it?
In the next billion years, we won't be able to have a solar eclipse.
Bummer.
Bummer. We're not gonna have to worry about it
I
though.
mean, what about the waves and the tides?
Like,
That's the thing you really should be worrying
Well,
about.
this will happen in a billion
I'm
years.
not
No one ever goes to the research it because
Because
it's
they
not
can
going to
just
happen.
measure it every year, I guess.
Yeah. You can see how it's moving.
So what happens if we can have a solar eclipse?
We just waited.
Yeah.
Would
Or
anything be
maybe
different?
An asteroid will
Well,
hit the moon
the
and not
tides
hit
would be
the Earth
different.
Yeah, that would mess up the our
Yeah,
tides and
it
stuff
will.
because of them.
in a billion years.
Yeah.
I don't think we'll be here.
Yeah.
If that source is correct. If that source is correct.
Right, and if that's not like an oscillation, we don't know,
Yeah, maybe it'll come
It
back.
just, yeah.
And people talk about that, people talk about how the universe is expanding, but will it eventually slow down, stop, and contract again?
And then another Big Bang.
And we'll just be like,
Well, but some people say it's actually accelerating. That's the kind of newest, most favored theory.
Okay.
Where does the
Again,
universe
how do
end?
they know that?
It's not only, well, I'll tell you, it's not only expanding, but it's expanding at a faster and faster rate. It's accelerating in its expansion.
Because they're seeing
which
more stars and
would
stuff.
not be what happened.
Oh.
Because if you think about the Big Bang, right, it would have lots of energy, but you guys know that things eventually always
Lose energy.
lose energy.
Well, there's not really a lot for
Right, there's not a lot of air resistance or whatever. But there's no explanation for the fact that if the universe really is accelerating, what's giving it the energy to actually speed up in its expansion? Like to be going slow, faster, right? They think now that the universe is not only expanding but accelerating.
Maybe
But
the
we'll
whole
talk about that.
universe is spinning.
Yeah, what do you mean?
Maybe it's triangle. I don't know. Who knows?
Yeah, we don't
Where
know.
is the end of the universe?
We don't know.
Is
We
the
can
universe
barely
flat?
find the end of the solar system, honestly, like, there's
No, giant sphere. Giant sphere.
How infinitely big it is.
I'm still
It's
talking about
amazing.
the
I can't wrap my
universe
mind around it. Just like,
And that
we
makes
feel so
sense.
tiny.
According
Like-
to the theory,
We are.
That does make sense to me because,
Not even
like, did you
close.
guys see that where the guy had the
Mhm.
flat.
sheet of spandex and like how they weeded themselves out based on one direction was favored for some reason? Well, that works in 3 dimensions, so things tend to weed out into one flat plane. So it makes sense that the universe has weeded itself out into a flat plane based on experiments that we can personally see. But that doesn't mean it's true, it just means that theory has some evidence.
This is
Where are we? Yes.
I read somewhere that the universe is shaped as a donut.
Donut shapes are
Like what's
popular
in the
and
middle, you just like fall out of like
Nothing.
jelly.
It's a black hole in the middle that makes the donut
Oh,
hole. The black hole in the center
nobody
is the
knows.
donut hole.
Really? I read this in a science book.
yeah, I mean, there are a lot of theories, and donut shapes also appear in lots of experiments. Like when you deal with like atoms and subatomic
What is the
stuff.
universe?
Donuts. D orbitals are like donuts, kind of. It's interesting. Let's see.
Many theories.
We're close enough to get enough heat from the sun. Obviously, we've talked about that before.
Otherwise, we wouldn't be here.
Okay, so going back to we can be skeptical when I say 8 billion years, but since the Milky Way is, by scientists in the mainstream, predicted to be 8 billion years older than the sun, that's the reason that we see heavy elements, is the theory. So we know the sun has helium and hydrogen as the vast majority of its mass. And the Earth is made up of heavier elements, right? Helium and hydrogen are number 1 and number 2 on the periodic table. We have lots of iron, lots of silicon, lots of carbon, lots of heavier metals and even heavier nonmetals. And the way that those get made are, at least we know, one mechanism for heavy metals and heavy elements to be made is the death of the sun, a death of a star, because the force required to cause heavy nuclei to be made happens during the death of the star. So if stars form and die, you tend to get heavier and heavier elements.
So are stars and suns the same thing?
Yeah, the sun is a
So
star.
why do we call them a sun? Why don't we just call it a star?
Our sun is just called, our
It's-
star is called the sun, but we don't, I mean,
Is that,
I
is
guess-
that the
Well, it's
scientific
giant in the sky, and so
You have to kind of think
we
about
just
this.
call
I
it
mean,
the sun
like,
because it's ours.
Right, but what's the scientific definition of that star, the sun? Is it just the sun?
It's a yellow dwarf.
No, like.
No, I thought it was a
some-
main sequence.
Some stars have
Yeah.
like the.
it's a main sequence yellow dwarf.
It's a yellow dwarf.
It's a main sequence
you gotta have to sound
yellow
like that.
dwarf.
But
One.
it's a main sequence star, but there are different types that, and we'll talk about that in a minute.
That's so cool to think of.
Is there do you have an average age of a star? Like how long a star can last until
I
it goes
think
into
ours is
supernova?
about average, and for yellow dwarfs, they usually last 9 to 10 billion years.
Okay.
Billion?
Quote, quote.
Our son
Isn't that
died.
crazy?
I read that.
Yeah, he's like, yes,
Stars
it's actually crazy. Thank you.
I read the stars originally start blue and then they start.
Yeah, but then we have a whole bunch of radiation and
Some.
stuff.
There are
that
many different types of stars, depending on their mass and their elements.
and also
You
the world
see
would
some
go dark.
differences
The
often.
world would go dark,
Okay, so
and we would die.
I'm just saying, some of the best evidence for stars being super old, and there is certainly evidence to say that God created the earth with its heavy elements just the way it is. That's certainly easy for him to do. But the star's death does create heavier elements, so if there weren't a God, then that would be the only process we know of where these heavy elements could come from. We know that our God can just create these heavy elements here. But just so you know, like, one of the reasons that scientists think that stars are so old is that heavy elements come from the death of stars, and then all of that stuff that,
It gets like
Is
dispersed
ejected.
onto other planets.
right, then there are clusters, they come together with gravity, planets can form, they have heavier elements that are formed during the death of the star.
What that would look like, the death of a star. Like,
What
not
we-
after
Is that a
the
falling
war.
star?
They're really cool.
That's a falling star.
No, that's just
No,
a
no,
meteor.
that's a meteor.
Ah, crap. Yeah,
Nope,
you're
not
right.
even a star. We know
A
that.
shooting
So
star.
why do people say shooting stars? They should say shooting.
Because ancient
Doesn't
people,
matter.
because
I
ancient
guess-
people named it that.
Just like we have all this, like it's called the sun because ancient people who didn't know all this stuff about stars and
Right,
galaxies,
it looks
they
so
just named
different
it.
than the other stars because it's
Isn't that
right
just crazy to
here.
think that that's a bunch of suns you're looking at? When you're looking
Yeah.
at
Well,
stars?
suns and
Some of them are much
galaxies,
bigger, some are smaller,
suns,
some are
galaxies,
burning other
all
elements.
that's planets,
Oh,
suns, galaxies, planets.
How does it glow?
It's just
Well,
that's right.
It glows.
Okay, so there's a good answer. The other thought here would be like, yeah, when there's a lot of space dust, gravity starts to attract, and when more and more mass collects due to gravity, then it has more mass, so it has more gravity, so more stuff comes, right? And so it will essentially, eventually suck all of the stuff in its surrounding area into one place. And then, because now it has a larger and larger and larger mass, it actually forms itself into a sphere because of the compression of the mass. So the sun, actually our sun, has sorted itself out. And as we talk about fusion that's going on in the sun, and it's mostly made of hydrogen and helium. Hydrogen is lighter, so as helium is formed in the sun, it moves in toward the core. So there's more helium than hydrogen right in the core because it's a heavier element.
Okay.
All right, I have a question. It doesn't have to do with the sun, but how come every time you see the moon in the sky with the sun in the sky also, it's not always a full moon?
What?
Like you can see a half moon in the sky during
Because
the day.
part of the moon
Sun,
is in shadow because of the earth.
if it's right next to the sun.
It's the angle.
What?
Like if the sun's here,
Oh, I
the
see
Earth's
what you mean.
here,
Yeah.
the moon could be like here, so only this
I
side
understand.
is
Yeah.
getting light.
It's the angle you're saying the sun. The moon. Although if you notice, if you look at it like a half crescent moon, you can actually see the whole moon
You
if you
can
look at
see
it.
Yeah. And if you're
So how
looking
do I
into
see
a
that?
dark starry
I
night,
get it.
you can see the void of stars where the other part of the moon is.
Why do
Okay,
planets glow?
because there's still like light
There's
in the
some
night
light
sky.
coming from other angles. It's just much dimmer than the sun.
Why do planets glow?
Because the sun
Why
reflecting
did
off
they
Because the
just
sun's
reflect
reflecting.
light?
Nuclear
And
fusion.
depending on, yeah,
No,
no,
they're not
planets
suns.
don't make their own light. They
Planets
just
don't
reflect
have
the
like
light
helium in the
that's
middle of it.
and they
Nuclear
reflect the
fusion.
light based on what they're made of too.
But they glow exactly like a sun star.
It depends on what they're made of. So the rocky planets reflect light differently than the gaseous planets. So yeah,
What are they reflecting light off of? The
off their
sun.
surface or their atmosphere, depending on if they have a surface or not. Like the gas giants don't really have much of a surface.
They have a lot of atmosphere.
Yeah, a lot of atmosphere. And the sun similarly is made of essentially gas heated so much that it becomes the fourth phase of matter, which is plasma. Joshua.
So since we're talking about planets and solar systems and that, I want to kind of ask you this question.
Oh,
Do you
gosh.
believe in aliens? Like bacteria kind of aliens?
Oh my goodness. That's like
So my
Yes.
first response, if they actually found that, would be somebody sneezed on the sample. If you work in a lab for
No, but-
more than 6 months, you will find that people are so careless, they contaminate everything, even when they're trying to be careful. So
Robots.
No, but like if a robot or a humanoid is
if it comes through our atmosphere, it's going to be exposed to our bacteria. As soon as you
Die.
open in a lab, no matter how clean you think your hood is, you're
There's
going to
no way.
contaminate your sample.
This atmosphere is so different from those planets to our planet. It's not even gonna make it.
have you
Yeah,
watched
I
sci-fi
can't even
movies that
imagine.
have spacesuits? Gosh.
It seems so realistic. No.
They always land in New York City. Why is
If
that?
they find alien life, I don't think, I mean, God did not
most
tell us
populated
that he only
city on
made
this
us.
awesome
It wouldn't be a
little
problem
continent.
for
Let's
me
go there.
space-wise, but I would be very, very skeptical unless they find an abundance of life in situ wherever it lives. I just, if a small sample would not do it for me. I would go contamination.
That's such a good point, though. They probably just sneezed on it and added something to it.
In a
Bacteria.
lab for
Yeah,
6
so they're
months,
working
see how
something
much
and
you
then
can
add
take.
it.
But,
They
do you,
breathe on
I
it?
said I never said. I said, do you believe in it?
No, it doesn't.
So
I would need to
no.
see
So
evidence.
would you say no?
Because like
It's
there's
a
so
no,
many
but
like
if it's
Or half and
discovered, it wouldn't be a problem for
So
me.
half and half?
That's a really good way to put it.
If there were
I
evidence
mean, how would I
of,
disagree if someone showed me that?
Right.
because
I
it may
wouldn't
be a
want like someone
fake.
to be like, oh, I found this video of this guy found an alien. Graphics are so good nowadays
Yeah.
that I couldn't tell the difference.
Yeah. You can't really believe what you hear these days.
Yeah.
Pretty much. I'm a skeptic by nature.
so,
It's okay. All right, focus. So the sun, special. We are far enough from dangerous stars and black holes. We're far from places where stars are still forming. This little piece of the universe is very, very peaceful compared to most
That's
places.
so cool to think
Yeah.
of, like how
I mean,
providential.
our nearest, it is providential. That's the only explanation because most places have stars much closer than 4.2 billion light, or 4.2 light years. Not billion.
And then the solar flares and like all those
Yes.
other like variables.
God has placed us in a wonderful, peaceful, happy place in the world where bad stuff just does not tend to happen like it does most places. Places where stars are still forming, radiation, terrible, crazy stuff.
Nebulas.
Spiral galaxies like the Milky Way tend to have areas of peace. Lenticular and what are those things?
Elliptical.
Galaxies tend to have much closer together, more concentrated stars. So there are not these little arms like ours that are more peaceful. We also are moving at the same speed as our arms, so we kind of stay far away from everything. We're not like accelerating toward another star, like
So wait,
in a way that is scary. Yeah.
wait. So
We're in
like,
the perfect place in
going
the
around
universe.
the sun, and then we're moving.
Yeah, the sun
Yep.
is
I
part
kinda
of the
thought- I kinda
expanding
thought, like-
universe,
I
and
kinda
the
thought,
Milky Way
like,
is spiral,
the,
so it's rotating
everything's
around
always
our
moving.
black hole.
I
The
thought
Milky
it
Way
was
black
just
hole
like
is the center.
still. I thought like
Uh-uh.
you'd see the
No.
thing and it was just
Of the
like
Milky
there.
No, it's like
So
slinky.
how do we not fall off into the black hole?
Well, the black hole has a huge mass, big gravity, and since we have a velocity perpendicular to it, we orbit it. The Milky Way,
So like everything's orbiting everything.
the Milky Way
Yes.
is a black hole, and everything spins around it,
Isn't that
and
crazy? to
we,
think how many things are orbiting something like everything's orbiting.
and the Lord
something
has
else.
protected us because I can't explain it otherwise. It's just amazing.
Let's not go into the
so-
death trap.
Okay.
Let's see.
Is it just
Did
too
you
much?
just get hit in the head? No.
Did you get a concussion?
There's
She
no
was
word
in
of
that.
that. We've had enough of that.
She got hit with
That's
information.
really funny.
Yes, we're hurtling through space alarmingly. Yes.
I'm so loud.
like skewed.
That'd be bad.
Talking so fast.
That'd be bad.
It's like a slinky.
Yeah, we're really far from it.
I'm still on
And this is going that way.
Like a little bit.
Whee!
Not messed up.
We'd probably be killed by radiation from another star, or
That's
and plus it's a
blood.
really long distance,
Well, we're
so
talking about things.
it'd be bad.
Okay, so we talked
It'd
about
be bad
stars
in the
and
distant
orbiting that.
future. Okay, so the sun is made of 74% hydrogen-ish and 25% helium-ish, leaving only 1% of other stuff that's not hydrogen or helium. Hydrogen is the lightest element, 1 proton, and sometimes 1 or 2 neutrons, sometimes not any neutrons. Helium, of course, is the second lightest element, 2 protons and 1 or 2 neutrons. Right, so the sun has parts. The core is the innermost part, just like the core of the earth is the innermost part. So the sun's core, this is where nuclear fusion occurs in the sun, which is what produces the energy that keeps us alive. Hooray. So the hydrogen atoms in the core of the sun are under huge pressure. Okay? They're intensely hot. So think, the core of the sun is very small. It makes up 10% of the total volume of the sun. It has 90% the total mass of the sun. 10% of the volume, 90% of the mass. It's incredibly dense. This is superheated gas, so it's plasma. And when you have superheated gas that has changed, my keys are stuck, into plasma, you end up with the electrons just being stripped away and carried off. So you end up with like this sea of charged particles. And so you have bare protons because hydrogens only have 1 proton, right? Hydrogen When you take away its electron, it becomes a positive ion, which is just one proton. And some hydrogens have one neutron, and some hydrogens have two neutrons. So you just end up with those without their electrons. So you guys remember how I said my hand doesn't go through the table because the electrons outside of my hand and the electrons on the table repel each other. They don't go through, right? So when you strip away those electrons, if you can accelerate those hydrogens, of course they're both positive, two hydrogen atoms with their electrons removed, or two protons, both positive, they want to repel each other. You shove them together, they want to repel. If you can manage to shove them together fast enough, hard enough, the right angle, then a pion gets exchanged, the strong nuclear force takes over, and they're stuck. Right?
Oh, that's cool.
Yeah. So then we've got helium, and that would be two protons and either one or two neutrons. And of course their electrons also are just in the soup, stripped off, because there's so much energy.
What strips it off again? Like, why is it just one? Why is it just a neutron? Like
Because
helium?
it's so much. Okay, so here I'll show you a little demonstration, and then we'll refer back to little demonstrations repeatedly. If I can get this, and I don't know if I can get it because there's like huge chunks apparently.
What is that?
So this is copper sulfate,
Okay.
and it doesn't matter about the sulfate part. It only matters about the copper part. So when we talk about how we think that things that are super far away are made of this or that or the other thing, and you're like, well, how can you know they're super far away? Well, we know about the behavior of elements on Earth. And where's my excuse this. I don't have any water with me, so MIT won't do the job. So we
What is that
know
thing again?
that when copper atoms get excited, their electrons zoom up into a higher energy state. When they zoom up into a higher energy state, what do you see, Jenna? Green? Do you see green?
I saw green.
Okay.
Hold on.
You ran out of the copper.
Watch
I don't
green
see anything.
flashing.
We're so.
It's not flashing green all the time. That's a lot easier when it's further sun.
Should lick your hands. So
It's hard to burn me. It doesn't happen often.
Except when you burn through a tube. I want to know how you did that. Yeah, burning through a tube.
Let's see.
Just lighting stuff on fire.
That's a bad video, I guess.
That's really funny.
Why can't we just light one of those little things on fire?
I guess we could.
It smells good though. I love the
Yeah, if
smell.
I set off the alarm, I'm going to be
Could you?
sad. I don't think with this, I hope. All right.
Funny
I'll stand over
Have you
to
set
the
off the alarm
thing.
before?
I have never. I hope it doesn't immediately do the sprinklers.
Well, I'm closing my book. Putting it under the table.
Oh, I see. All the carpet is sprinkled.
I want to light one of those chunks on fire.
That's actually really fun class.
That would be a fun class, actually. Go under the table. Alrighty, Mrs. Mathias, I'm ready. I'm ready for you.
You guys need that.